Alright, this is the last week before AP exam week. It's 2010 number 5. Got a little question with a bunch of Lewis structures to look at. I don't think you're going to have to draw a Lewis structure, but there's some good questions coming from this. So here we go. It says use the information in the table below, respond to statements and questions that follow. So they give us a bunch of different compounds that start with eth, right? Which means there's eth is for 2, so there's 2 carbons in each of these compounds. And it says to draw the Lewis dot diagram for ethine at the end here. I've talked about it before in class that ane endings, anes, means saturated hydrocarbons where there's no double bonds. Ene endings, ene, means there's a single double bond, and then ine endings means there's a triple bond somewhere. So this guy, you know the carbon's got to go in the middle. I still think you should count up valence electrons. There's 4 in each carbon, so that's 8. 2 more for the hydrogen is 10, so 5 pairs. So there's symmetry here, which means one of those hydrogens is going to come off each of the carbons, and then we still have 3 pairs left. And the only way to complete the octet for both of those carbons is to have a triple bond in the middle. So it looks like that. Then it says in part B, which of the 4 molecules contains the shortest carbon-to-carbon bond, and explain. And the answer is the one we just drew. So on B here, ethine here is going to have the shortest carbon-to-carbon bond, and my explanation is the bigger the bond order, the shorter the bond length. And you might as well say ethine has a triple bond, even though you've already drawn it. That's part B. And on part C, it says a Lewis electron dot diagram of a molecule of ethanoic acid is given below. The carbon atoms in the molecule are labeled X and Y. Almost every time you deal with a ternary acid or an oxyacid, it's hydrogen to oxygen to the rest of it. That's what we see here. And it says identify the geometry of the arrangement of atoms. Pull this bad boy over. So identify the geometry here for carbon X. Carbon X is the one sitting here. If we look at that guy has 3 things connected. That carbon, that oxygen, no lone pairs of electrons, which makes that guy trigonal planar. 3 things connected, no lone pairs, trigonal planar. Carbon Y has 4 things connected, the 3 hydrogens and that carbon, no lone pairs on the central atom, and so that guy is tetrahedral. Those are your geometries for each of those things. Easy enough. You need to go back and look at them. You should go through and look at all those shapes. You could get a shape question somewhere along the way. Then it says energy is required to boil ethanol. Consider the statement as ethanol boils, energy goes into breaking carbon-to-carbon, carbon-to-hydrogen, carbon-to-oxygen, oxygen-hydrogen bonds. Is that statement true or false? This is a little bit of a trick question. If we're dealing with boiling point, we are dealing with intermolecular forces, not with bond energies. So if you boil ethanol, what do you have? You still have ethanol. So there's no old bonds that were broken or new bonds that are formed. So the statement is false. Boiling ethanol only breaks intermolecular forces not individual bonds. There is no, I would write, there's no chemical reaction so no bonds have been broken. That's it on part D. We're not breaking those bonds. It's boiling, right? Phase changes are just separating of the intermolecular forces. Part E says identify a compound from the table that is nonpolar. Justify your answer. You have two options here for nonpolars. This guy's dipole-dipole forces. That guy has hydrogen bonding, right, which is a dipole-dipole force. Ethane, that saturated hydrocarbon, is nonpolar. Ethine, and the one we drew at the bottom, also nonpolar. So either one of those. So I'm going to choose ethane for fun. Either one of those would be fine. Ethane is nonpolar because, and this is the explanation over and over, because all the dipole moments cancel. That is your go-to verbiage there. All the dipole moments cancel. That's why ethane is non-polar. And then ethanol is completely soluble in water. Ethanol is limited solubility. Account for the difference in the solubilities. When we look back up at those two, I just talked about them. That guy's dipole forces. This guy has hydrogen bonding, so the hydrogen bonding is going to attract the water molecules more and is going to be more polar and therefore is more soluble. So ethanol is about polarity. Ethanol has hydrogen bonding. Where I gotta try to spell this other one right. Ethane thiol. I probably spelled it wrong. That'd be funny, huh? If I said I'm gonna spell this right and I spelled it wrong. I'm not looking. I'm just gonna assume I spelled it right. Ethanol has hydrogen bonding, where this other guy only has dipole forces. The hydrogen bonding causes more polarity and therefore ethanol is more soluble in polar water. That's it. Let me get the answer on the screen. That's it. The polarity of the water is going to attract the hydrogen bonds on the ethanol and cause that thing to dissolve. That's it.